Hello, everyone. Thank you for participating in today's webinar. Just first of all, just a little bit about Cincinnati. I work for the Cincinnati Park Board, and we have a very extensive park system. We have about 5,000 acres of park forest and land, which is about 10% of the land in the city of Cincinnati. And a lot of it is topography that is not very desirable for building on. We have a lot of hillsides and valleys and streams and green corridors that the decision was made to preserve as parks for good reason. And therefore, they're also very conducive to doing green infrastructure projects, which I'll talk about more. But we also have a very old sewer system. We're one of 772 cities in the United States that has a combined sewer system, which I'll explain in a moment. But we rank 5th in the nation for urban combined sewer overflow volume. We have 105 overflows a year, and some combined sewer overflows resulting in 11 billion gallons annually flowing into the waterways. This is sewage that should be going to the treatment plant, but we get so much rainfall, the system can't handle it. It overflows into our streams and ultimately into the Ohio River, where millions of people get their drinking water. So it's not a good situation at all. So what we've done historically was we took streams that flowed over land, and in order to develop the land, we put them into the sewers below the streets. And so today we have, of 300 miles of streams we once had, we now have 75 miles of streams with over 600 miles of combined sewers. It's a really big problem here in Cincinnati. So the way combined sewer systems work is the water typically flows on the pervious surfaces along streets and into the inlets, or from rooftops and gutters down to downspouts and into the sewer system, where when we have dry weather, it's not a problem because the system can handle all of the water. It goes to the treatment plant and it's treated, and it's clean water is put back into our streams. But when we have heavy rainfall, it overwhelms the system, and rather than having it back up into people's homes and basements, there's a combined sewer overflow installed in approximately 200 locations where it flows into streams. So our sewer treatment is handled by the Metropolitan Sewer District of Greater Cincinnati. They have 43 of the 49 communities in and around Cincinnati and small parts of Butler, Claremont, Warren counties, and entirety of Hamilton County. So they have a big job to do, and they've inherited a lot of issues with the antiquated sewer system. So right now we have 212 combined sewer overflows where raw sewage flows into our streams and ultimately into the Ohio River. So the Metropolitan Sewer District and the city and the county, which operates the city operates the sewer system, the county owns it, signed a consent decree with the U.S. EPA and agreed that they will capture, treat, or remove at least 85% of the 11 billion gallons of annual overflows from combined sewer overflows and eliminate all overflows from sanitary sewers, which is about 100 million gallons annually. Already there's been some progress made. We started off at 14 billion, and now we're down to just a little over 11. So there's 3 ways we can do this. The first one is what we're going to be talking about mostly today, source control. What source control is preventing the stormwater from getting into the combined sewer system in the first place. Typically this is done through separation, through putting the water back into streams, or biofiltration, or rain barrels, or rain gardens, or the type of things that most people associate with green infrastructure. The second one is conveyance and storage. There's a lot of cities in the U.S. that are building deep underground storage tunnels where the combined sewer flows would flow into during heavy flow, and then it would be pumped out and treated at the sewer treatment plants. That was one of the options that the city looked at as part of the consent decree. And the problem with that, well, there's several, but the big one is the public is paying for infrastructure that is buried underground where it's not really benefiting communities, as well as the fact that the stormwater has to be pumped out and treated, whereas if it's separated through source control, you don't have those issues, and the separation projects could be visible in the landscape in the communities where the ratepayers are paying for it. So most of the work that we're doing here in Cincinnati is through source control. The third option is product control. That's making more efficient wastewater treatment plants that can handle more volume and clean the water at the bottom of the watershed. So when the project was first starting, the consent decree was kicking in, and the sewer district was looking for options. We formed a partnership with them. Again, part of it is because we own 10% of the land of the city, but also because we have people that are knowledgeable about a lot of green infrastructure. We manage the city's street tree program and park forest, which is 5,000 acres. So we have a lot of opportunity within the park system to abate stormwater. So we pretty much worked on three parts of it. We focused on inspections, both in public projects as well as by private or nonprofit partners. So we would go in when the project started, do documentation, look at things like erosion control and things that can contaminate biofiltration. And we also constructed green infrastructure projects using park contractors and personnel. We did a series of projects, which I'll show you a slide of in a moment. And then also do maintenance of green projects, primarily landscape type work, mulching, deadheading, weeding, those kinds of things. So we worked on several different types of projects for MSD. A lot of them were swale. The first one on the left is rooftop separation. We directed the water off the roof through downspouts and into a biofiltration swale where most of the water is absorbed. The second one on the right is a double biofiltration basin. It's water that runs off of a hillside in a parking lot and flows in. There's a first basin fills up, and then there's an overflow that fills the second one that's lower down over the hill. And we also did projects such as pervious paving systems and parking lots. The one on the upper left is a church. The way that the program works is MSD funded the improvements, but the church agreed to maintain them. So this is one that we actually built. And then the one on the right is a stream daylighting project where the water from the park flowed into the combined sewers. So the stream was re-engineered to handle additional water, and then the inlets were closed off, and the water now flows through the park as opposed to into the combined sewers. So the whole idea behind doing green infrastructure projects as opposed to the deep tunnel is to try to address our goal of triple bottom line approach, which weighs the economic, social, and environmental cost benefits of a project. So the economic part of it is what we're talking about today, jobs, business, and growth. The social part of it is community revitalization, parks, and then the environmental part of it is the clean water, the stream ecology, and human health. And so MSD has branded this series of green infrastructure projects as Project Groundwork. And you can go to their website if you're interested, projectgroundwork.org. So when the project started, MSD estimated that there would be nearly 900 full-time jobs, construction jobs needed to build these green infrastructure projects in the lower part of the watershed. So it is really a big impact on the economy and on the workforce. So I took the study that Sara talked to you about, and I went through and pulled out all of the jobs that were identified, potential workforce needs for future green infrastructure projects. And I took one of the projects that we worked on. This is a project at the Cincinnati Zoo and Botanical Gardens that we inspected. So this is rainwater harvesting, which it's a big project. It's 119,501 gallons a year, and biofiltration of 3,500 square feet, and where the stormwater is stored and used for irrigation throughout the zoo. So these were built for storage and just for this part of it, pipe layers, plumbers, environmental engineer, excavating and loading, operating engineers, helpers. There was concrete work associated with it for part of the zoo attraction. So there were cement masons, concrete finishers, laborers, truck operators, supervisors of construction. Construction laborers, helpers, plumbers, paving. Now, while this is a little more intricate and different than most of the projects we worked on or built, you get the idea that there are a lot of different levels of workers necessary for projects like this. Plumbers, water system operators, electricians, valve operators, pump operators, inspectors, these are all positions that were identified in the study. Arborists, landscape workers, groundskeepers, laborers, truck operators, nurserymen, and we're almost there. And this is what it looks like almost completed. And there's still people working in the back, primarily landscaping, which comes in at the end. And it all results in one very happy lion and happy zoo visitors and the removal of hundreds of thousands of gallons of water from the combined sewers where it's used and repurposed back into the landscape at the zoo. So of that one project, all but 2 of the positions identified in the study were used on that one project. And then there are others. I mean, obviously the study didn't cover the design professionals or some of the other professions like geotechnical or landscape architects or those type of occupations, but kind of entry to mainline level construction laborer positions, we covered most of them. So pretty quickly after MSD started working on these projects, they realized that they needed a trained professional workforce to construct, inspect, and maintain the green infrastructure that's being built to landscape scale in multiple watersheds. It's a big program, and green infrastructure is pretty much a new, not brand new, but it's a relatively new field. So there aren't a lot of people who already have those skills who are ready to just jump in and do the job. And while it's not really difficult to understand what goes into it, you have to understand what goes into it and how things are constructed and how things are maintained in order to keep these things functional. Our friends, the gray side engineers, their big concern with green infrastructure projects is that when they aren't maintained, then they become more of a liability because their performance can't be valued. So I think as the green side of the field, we need to continue to increase our professionalism and our ability to inspect, maintain these things. So anyway, we formed a partnership between the Cincinnati Civic Garden Center, which has been around for 75 years. And what they do is community gardening, horticulture education, and stormwater education. And their mission is to build community through gardening, education, environmental stewardship. Then there's also a new certificate program. It was started in DC last year called the National Green Infrastructure Certification Program, or NGICP. What this does is sets national certification standards for construction, inspection, and maintenance workers, meets international best practice standards, advances sustainable communities by promoting green infrastructure, develops a proficient green workforce, and establishes a career path for skilled green infrastructure workers. So as I said, it was initiated by the District of Columbia and the Water Environment Federation. There's 13 partners now, 13 cities around the country where the certification program is being taught. It's led by a governing body and includes strategic planning and technical advisory groups. And there is a test, there's an exam that provides confirmation that the level of understanding meets a basic threshold. It requires 35 hours of training with a mixture of classroom training, lecture presentations, some group exercises, but also in-field training, site visits to green infrastructure practices and sites, mock inspections, and making sure that they understand the components of green infrastructure, how they work, how to inspect and maintain them. So the Civic Garden Center was a perfect fit for our program here in Cincinnati to prepare people for the certification. We have what's called the Green Learning Station that was constructed about 5 years ago. And what it is, it's a demonstration project of stormwater best management practices. There's a series of different pervious type pavement. The green is, the building is very green. I believe it's silver LEED building standards. And so the training content will be presented there, the bulk of it, and it covers things like the introduction to stormwater management and green infrastructure, materials and vegetation used in green infrastructure, practices and systems, safety site management, managing for long-term performance. And we have just the perfect place to teach it. There will also be some field trips for stormwater management, composting, and the training content also covers the construction of bioretention, permeable porous pavement, rainwater harvesting, green roofs, dry wells, constructed stormwater wetlands. So these topics will be presented by local professionals who have pretty much volunteered their time to do this for the advancement of the certificate program. We have a couple experts on things like green roofs that will be part of it, as well as the surrounding sewer district and a few other organizations. We also have 2 different types of green roof. So there will be inspections and planting and weeding and maintaining green roofs as part of the curriculum. And again, as I mentioned, there are several different types of pervious pavement systems which actually have sensors, so you can measure the amount of water that's being absorbed by them by type. There's pervious concrete, asphalt, pavers with different underlayment, different types, different sizes of aggregate. And also rainwater harvesting. There's a 2,500-gallon rain tank. The water is directed off of the rooftop, and that water is used for irrigation systems. Also a bioswale that exists on the property. So the participants in the program will be out there weeding and maintaining and planting and unclogging and doing all the things necessary to make the green infrastructure perform as designed. And you can get more information at the National Green Infrastructure Certification Program website. It's here. This is a link to the exam blueprint so that you can see what's covered. The training will be for a minimum, we think, of between 25 and 50 people. The cost for a for-profit company is $400 per person that attends. For a nonprofit organization is $250, and there are scholarships available. We hope to reach, have a percentage of the class to be unemployed or underemployed workforce participants. The only qualification is that you have a high school diploma and that you complete the 35 hours of training and that you pass the exam. And that is it for Cincinnati. Thank you.